Yeah, and now there's a new this introductory exercise. So we're going to try to program a moving average filter, or gliding average filter, basically where we take an average of some measurements that we have been sampling, that we've been input and put into a register, and take an average calculation of that. This is this one. It's data. You can use that also for parameters, but it's program this function block. This program that should call here, or call in program main or something. Someone should get to execute this instance data block and test it in the instance data block. Okay, so what we are going to do, moving average filter, call it function block moving average filter, where this FIFO, and you can Google FIFO, use ChatGPT, ask what a FIFO is, first in, first out. So this is an array where the first entry is going to move out. So it's just they're going to drop down through this array, and then they are going to disappear on the end. So that's kind of a FIFO. A LIFO that we had before was the last in, was the first out. The top, you put something on top and remove it from top. So you can't remove something on the bottom, but that's what you can do here. 100 real numbers that we can take an average of. Maximum length should be set using a constant. Start index 1, FIFO top maybe we could call it, and this going to long real, 64-bit real values. Boolean input enabling the filter, switching the filter on. When it's not enabled, the input should be directly transferred to the output of the filter, doing nothing. Okay, but you should maybe prepare something in the filter. Maybe you should initialize your sampling time and things like that. Input X, which is the one that's being average, along the output Y, which is the average of the entries in the FIFO at any time. And from the first index, the parameter number of entries, which should be between 1 and 100. So we don't have to use all these 100 values if we want to. The function block, retain integer, pno, so which is the parameter, actual number stored in the FIFO. PTS is the sampling time for the filter. How often should we input something in the filter and do the calculations every second, 500 milliseconds, 2 seconds, 10 seconds? We don't know. But it is a parameter for each sample. Yes, okay. Yeah, default values for the PTS should be 10 milliseconds, so that's something we're going to look into. Test the function, like so. What we get to know is always this OB, a function. We make the call, a function block, an instance data block. We need if, then else if, for, to statement, array handling, timing for sampling, retain parameters, parameter validation, this pno, which can be less than 1 and greater than 100. We have to make sure that it is in this array. And then it's these default parameters, this one, how to do this. And now there are some programming tips too. Suggest a function block interface. We talked about XE, enable filter. X, what we're going to take the average of, the number, the sampling time. There is the default value. Just put them in here, and the output long real, we don't have. For the timing system, we need to store some values. There are these two and this one. And then, of course, we need a FIFO, and that has to be static, because between every program call, this is being iterated. And so it's doing one calculation, waiting for some time, doing a new calculation. Of course, we have to keep the elements that we enter into our array, that we have to keep them between all these calls. Retain parameters we are looking at, and here is some for calculation if you need it. And there's a temporal for the input and for the output, because this is the right naming that we're using. Temporal long real Y, so that has to do with this one. Temporal long real X has to do something with this one. And TIP no has probably something to do with this one, and so on. And then we have an index, because we have need an index into our array here. And then there's something called a TB restart here. PLC restart indication, because what should we do when the PLC is switched on for the first time? This one is not retain, and we can't retain it because the PLC maybe has been switched off for half a year or something, and all the values in here, they are going to be 0. So what should we do with a restart? A restart is a special function in this project template that's called getFirstScan that you can call to get an indication it's been restarted. But what should we do on a restart, a new start? Maybe we should initialize the filter or the FIFO when we restart and things like that, and initialize our timing system, and so on. And here are the constants, and this maximum timer value that we're going to use in the timer calculation. And here, timing should be performed according to so and so. And this timing system you can copy from the first exercise. There's a little timing in there. So in the static section, we have to store the last sampling time, or last time, and then we have to do some calculations here. And here is shown how to do this. And also, as this time tick is between 0 and a maximum value, this here, and it's wrapping around, this one can be negative, and then we have to do a little trick if it's negative to get the correct time value out here. And here is if TT time greater than time set point, which we call the sampling time, do something, and then initialize the sampling timer. So you start to do a new counting. Maybe you should do something. Should do this first and then do something. Do something is here. Okay, roll down the FIFO, put your new value on the top, do a calculation of the average and output that average. That's the do something in here. So here's part of that, but also you have to have a little up here with the restart and stuff like that. So there's more to the program than just that. This is just a snag from the compendium. So function block internals, what we have to do, here's the FIFO, and for every sampling we have to move the second last one to the last one, the third last one down and down, down, down. So it's 3 on the top here, and put the X onto the top, and then we have to sum all the values and calculate the average based on this one. Here's basically the formula that you have to use. Here's the declaration of the array, which we looked at up here too. And this is the sum, something like this, and the sum here, maybe it's a for to loop. Okay, and this has the sampling time and numberage for averaging. Maybe this one has to be validated in your program. The last one here goes into the bucket. It's gone. So that's the first in, and it's also the first out. So it just disappears. Restart handling, we have the FIFO, first in, first out handling, sampling time handling that we looked at, and averaging. It's pretty much this. And here's a selection. If it's not enabled, this X should maybe be transferred directly to the Y, because that's what is specified. So something like that in here. There's no pseudocode. So what you should do, but then I go according to how we program, is that we have temporaries. You assign values to temporaries, validate your inputs, handle this timing, the sampling timer, do whatever you want to do, and write the result to the output, do the calculations, or something like that in your coding section. The context here is just a part of it. This could be an anti-aliasing filter, which is filtering the input to a PID controller, which is in the program template too, with some parameters here for gain and integration time and so on. Goes to a control valve, and then we have some level metering here in the tank, where we use another function in the template, scale analog input. And here it could be a scale analog output, but this level controller has a format, a number format we use by 4020 milliamps control valve, for instance. Yeah. So here is some. The P parameter output high range is 100, because maybe the level here was 0 to 100% and so on. An LT 100, which is then level transmitter 100 for this time. here. And here is just we have these pictures from Anderson Hauser. They make lever transmitters, and here's the flow control valve from a supplier too for flow control valves. So that was the context here for this moving average filter. Should be a G in here, and there's probably some typing errors elsewhere too. So this was an exercise where we are going to program a moving average filter, but it is basically, let's say, array handling too, and if and else if and for two statements that you have to use, parameter validation and so on. So this is what the exercise is about, but it's handling an array. Because array is an element where we can store values or similar values, and we can use for FIFO or LIFO that we have done before and do a little program. So it's just to try this. Of course, there's going to be a suggested solution afterwards for this one too. But just try to program this a little according to this video and the programming tips that you got.